Hey, Dion. Uh, let's see. I'm going to try to get Deborah back in. How you doing, Tierra?
You know, I'm really getting tired of this mute and unmute thing because I usually hit my space bar and it'll unmute, but it hasn't been working lately. But I'm good.
Okay. All right. Deborah's trying to get in, but she must be having some difficulty. Ah, there she is. Do you have trouble getting in, Deborah? The first time?
I guess so, yeah.
Yeah, I couldn't see what your video wasn't coming up and your audio wasn't either, but you're here now. Okay. So, guys, I just glanced at my email to see who had sent in the quiz. There was one on there that was hard to read, and I know you probably know what I'm talking about. The last one.
Yeah.
It should have been 2 n cubed minus 1 in the bottom, but I'll grade it for whichever. You can do it either, whatever. I don't know what you thought it was. Okay, so I'll look at what you thought it was and how you wrote it down and grade it based on that. Okay, so I think I couldn't even tell what I intended because that was my original copy, and I think it was n cubed over 2 n cubed minus 1 was the an on it. So I'll look at it and make adjustments as I need to. Anybody have any questions? I didn't quite finish what I wanted to say yesterday, so I'm going to kind of pick up where I left off. We were talking about power series. You may or may not have gotten to that homework, but the power series, the big deal about power series is you use the ratio test.
Can we look at one of the problems for homework?
Say that again?
Can we look at one of the problems from homework?
Yeah, sure. Tell me which one you want to look at.
Number 3.
Number 3 on, the one that was
72.
The one with that I didn't know whether it was the cube or not?
No, in the book.
Oh, in the book. Okay, tell me what page then.
572.
572. All right, let me find that and then I'll get shared. So you said number 3, right?
Yeah.
Okay, on 572. Sure, that's a good place to start actually. So let me get everything shared. Hi, Lexus.
Hey.
I got bumped out last time, so last class, right when I was getting ready to give them the punchline. So if I get bumped out, I'll be desperately trying to get back on, guys. You guys just take a break. Okay, let's see what we got here.
Which number are we doing?
Number 3.
We're doing number 3 on page 572. So let's try that one.
Oh, you got it.
All right, let me get back to 101. I'm somewhere else. I'll bring let me bring up the lecture and then I'll get some spare pages on the back of it. So hang on one second here. We're on basically on power series. Is this the one I wanted? Let me try it. This may or may, I did 2 versions of this lecture. That's not the one. That's why I did 2 versions of it, because that one looked bad. And actually, here we go. Yeah, that's what I was doing yesterday. Okay, so so let's go down. Tara wants to look at number 3 on page 572. That's a good one to start with. So number 3 on page 572 looks like this. It says find the interval of convergence of the power series, and it's n squared over 2 to the nth. N squared over 2 to the nth, x to the nth. That's how we know it's a power series. It's got that x in it. And it's going from n equals 0 to infinity. We're going to try, all of these problems are basically ratio test. So we're going to look at the ratio test first. So stop me if you got a question. That'll be the limit as n goes to infinity. And this will be n plus 1 squared. X to the n plus 1. I'm putting in n plus 1 everywhere there's an n in the top. And that'll be 2 to the n plus 1. All right. And then I'm going to divide by n squared x to the n over 2 to the n. Okay. So when I invert and multiply this thing, it's going to take me a couple pages on these little pages to do it. But it's going to be n plus 1 squared, x to the n plus 1, 2 to the n plus 1. When I invert and multiply, it's going to be 2 to the nth on top. So I'm inverting that. N squared x to the nth. All right, let's simplify it and see if we can take the limit. 2 to the n over 2 to the n plus 1. Let me move this. I can't see my screen here, so let me get rid of that. Okay. The 2 to the n over the 2 to the n plus 1, the 2 to the n goes with that 2 to the n, and there's a 2 to the first left. Okay, so I'll be looking at the limit as n goes to infinity of down in the bottom, there's going to be a 2. What about x to the n plus 1 over x to the n, guys? What's that leave me with? X
to the n plus 1.
Well, x to the n plus...
First.
Well, yeah, if you take away, if you subtract the power down here, it'll be n plus 1 minus n, so it'll just be x to the first. Yeah, that's right, x to the first. So I end up with x to the first here. So there's just an x right there. So that takes care of the x's. Then I'll get n plus 1 squared in the top and n squared in the bottom. Okay, now one way to think about this, guys, is to sort of, I didn't do a lot of this yesterday. I sort of did it all in one step, but you can take out the stuff that doesn't have an n in it. So in other words, you've got the absolute value of x over 2, and then you've got n plus 1 squared over n squared. And that's the thing that has the n in it. So we're looking at the limit as n goes to infinity of that. Now, Kira, your question, what's the limit as n goes to infinity of this thing right here? Look at the powers in the numerator and look at the power in the denominator. They're both what? What's the highest power up here? Anybody?
It's gonna go to 1.
Yeah, it's going to go to 1 because I'm going to have a 1n squared. You don't have to take the time to multiply it out. You know that n times n is going to give you a 1n squared. So that whole thing right there is going to 1. So here's what the ratio test says then. Once you get all that, what you're left with is the absolute value of x over 2, and the absolute value 2 is just 2. So here's when it converges. All right. The ratio test says it converges for the absolute value of x over 2 less than 1. Whatever that limit goes to, less than 1. What that says is that the absolute value of x is less than 2. And what that says is that x converges between 2 and minus 2. Okay? So basically, at this point, what we've got is, if we look at intervals, this will be from minus 2 to 2, where I know it converges. Ratio test says is if it's bigger than 1, in other words, in this case, bigger than 2, we know it diverges here. Oops, I'm back in calculus, writing concave down. Ugh, weird. So what that thing is going to do is diverge there and also diverge to the left, okay? So the only thing I have to do now is check the endpoints. So Tiara, tell me where you had a problem. Was it up to this point or when or now?
No, at the top with the x to the n plus 1 and the x over n.
Okay. All right. What you see up here, guys, when you look at that, if you just look, I'll just scribble it right here. X to the n plus 1 is just x to the n times x to the first. So if that's over x to the n, all you're left with is an x to the first. That's what that's all about.
What I'm confused about is like, I think I was thinking about this differently. because I got to the 2, like the -2 and the 2,
Mm-hmm.
and when I tested it,
Mm-hmm.
I got like the 2 was included and -2 wasn't.
Okay.
But in the back of the book, it said they were both not included.
All right, let's look at both of them then. Let's see what we got on both of them. The series, I'm going to put 2 in. I'm going to check -2 first. Oops, that's not what I wanted to do. Yeah, go back, go away. Okay. So I'm going to check x equal -2. All right. So when I plug that in here, I'm going to get -2 squared. It'll look like this: -2 squared over -2 to the nth. I'm sorry, what am I doing? I'm doing something stupid. Hang on just a second. I just need to plug in the -2 to the x. Sorry, I don't know what I was thinking there. So it's sum. Let's see, it was n squared over 2 to the nth. N squared over 2 to the nth, and then it had an x to the nth in it. So I'm going to put in -2 to the nth, because that's the x I'm checking right there, the -2. Now, I'm gonna rewrite this. It might help guys to see it as something you're more familiar with. N squared over 2 to the nth. That's the same as -1 to the nth times 2 to the nth. If you just write this as -1 times 2 and just raise each one of them to the nth, it'll show you that thing right there. You're looking at an alternating series here. Okay, so, and not furthermore, the 2 to the nth, once you plug in things in there, the 2 to the nth cancel out. So now let's think about it as an alternating series. What has to happen in an alternating series? The nth term has to go to 0 as n goes to infinity, and it has to be decreasing. Does that go to 0 as n goes to infinity?
No.
Nope, goes to infinity. So this one diverges. So what that says is I'm definitely not going to include -2. I couldn't remember. I don't remember which one you said you.
I said that the other 2 was included, but the book said it wasn't.
Okay, so you were okay with this one then, right?
Yeah.
Alexis, okay. So let's check 2. Let's check x equal 2. So if I check x equal 2, it's going to be n squared over 2 to the nth, and I'll still put a 2 to the nth in there. Oh, 2 to the nth. I'll still put a 2 in for x, and that'll be the sum from wherever n equals 0 to infinity. And you still see you have a 2 to the nth right there. And what happens to those 2 to the nths here? They still cancel. And now you got, oh, it's not alternating anymore, but you still got the nth term divergence test. If this thing doesn't go to 0, it's going to diverge.
See, what I was thinking was like, it's a P series. Okay, I see what you're saying.
No, it would be 1 over n squared if it was a P series.
Oh, okay.
Right? It's 1 over P squared. It would have been 1 over n squared. And if that had been the case, it would have converged, because it would have been a P series with P greater than 1, okay? That makes sense?
Yeah.
So guys, the interval of convergence here is -2 to 2. Neither endpoint was included. Okay.
Can we do 5?
You want to do 5?
Wait.
Wait. I'm waiting. What, Dion?
I don't even know how y'all got the 2s. Who did you get the 2s?
Okay, if you look at the original problem where we had to find, we used the ratio test to find the limit as n goes to infinity of this thing right here. This was the function, the series with n plus 1 plugged into it, and then this was the series un. When I inverted and multiplied that and did all this work here, are you okay with that, Dion? When I did, okay. So when I did all that, I found out that this limit right here, that's what's got n in it. It's going to 1. I get absolute value of x over 2. The ratio test says this thing will converge if that limit right there is less than 1. So that's where I did all the legwork there, and I said, okay, it's going to converge there. The next thing I did was multiply both sides by 2. And we know if the absolute value of an x is less than a number, then that number is in between that number and minus that number. Okay, everything in between -2 and 2 has an absolute value less than 2. And that's where it converges. You're going to set it less than 1. So that right in there is where it converges. It will diverge outside that because the ratio test says if it's bigger than 1, look at this, if you say absolute value, sorry, 2, that, if you think about what that means in absolute value, it means x is bigger than 2 or x is less than minus 2. So I'm sure it diverges on the outside, it converges on the inside by the ratio test, okay? And then I just check those endpoints. Did that answer it, Dion? Got it? Okay.
Every time we do this like type of test, we're using the M test.
Yeah, the
Okay.
ratio test.
Like when we check the points.
Oh, when you check the endpoints, it could be anything. It could be an alternating series. It might be a P series, like you said. You've just made it into a series, and now you have to fall back on all the stuff you learned before we got to power series, because now you're just doing it for a particular point. Okay. And I plug that point in. All right. Now, somebody said, who said 5?
I did. I think I messed up on like simplifying things.
All right, well, let's look at it. Let's look at it. This is important, so we'll look at it. The sum from n equal 1 to infinity. The sum, this is 5, from n equal 1 to infinity of minus 1 to the n minus 1 over 1 over the square root of n x to the n. Okay, so I'm going to use the ratio test on this thing. I'm going to say the ratio test tests for absolute convergence. So that's a good thing for this one, because actually it is alternating. This part of it is alternating, but this is a power series. And I might have to use the alternating test when I get to checking the endpoints, but to begin with, I'm going to use the ratio test. So the limit as n goes to infinity of minus 1 to the n plus 1 minus 1 over 1 over the square root of n plus 1, x to the n plus 1. I just go to the series, everywhere there's an n, put in an n plus 1. In the bottom, I just put the series, or the nth term of the series.
Yeah.
Okay. So let's simplify. The limit as n goes to infinity then. This is, the ones go in that. So right here, I've got minus 1 to the n over minus 1 to the n. That whole term's done, okay? The next thing I'll look at, what's x to the
I
n?
could just go ahead and cancel those terms, like the negative one.
Yeah.
So whenever I see that, I can just go ahead and like basically.
Yeah. Well, yeah, yeah.
Okay.
Sometimes.
I know that.
The reason sometimes, but in the end, it doesn't matter what minus 1 is raised to, because the absolute value of minus 1 is going to be what?
1.
It's going to be 1. So it's going to take care of itself. The reason I canceled it here is because they were both the same. Okay. Still, even if they weren't both the same and you got minus 1 to the nth or something, absolute value, that's just going to be 1. All right. So how about x to the n plus 1 over x to the n?
I said x to the first.
X to the first. That's right. Because that's the same as x to the n times x to the first. So x to the n's cancel. So I'll get an x to the first there. And then what's left, if I invert and multiply, is the square root of n over n plus 1. And notice, guys, I put them both under a radical because they're both under square roots. And the reason for that, I'll show you. It's a quicker way to look and see what's happening. So I inverted this, put them both under the radical. Now, we know from Calc 1 that the limit of a root is the root of the limit. So what I wind up with here is that x out there is absolute value x. Now, look under here. If n's going to infinity, what's that going to?
1.
1. And the square root of 1 is 1. So I get that. That converges when the ratio test said the series will converge for absolute values of x less than 1, which says x is between 1 and minus 1 here. So far, what I know is that I've got it converging between minus 1 and 1. It diverges outside the 1s. Now I got to check the endpoints. Everybody okay to that point?
Yeah.
All right. So let's check the endpoints. Let's check -1 first. Let's check x equal -1. When I plug it into the series, I'm going to get -1 to the n -1, -1 to the n -1, 1 over the square root of n. And then I'll plug in -1 to the nth. Okay, because that's where the -1 goes in where the x is on the series, guys. Okay, so what I get is let's combine these -1s. There are powers here, guys. So what I get here is if I add powers here, both of them are -1. If I add those two powers there, I'll get 2n -1. So it's -1 to the 2n -1, and it'll be 1 over square root of n. Okay, now an interesting thing happens here. Let's write out a few terms from this thing, because you might think it's alternating, and it probably is, but let's look at it. If I write out a few terms here, if I let n be 0, let's see, did this one start at 0? This one started at 1. N equal 1 to infinity. I'd have 2 times 1 minus 1 would be 1, so that would be -1 is over 1 over the square root of 1, which is that, okay? The next one, if I let n equal 2, it'll be -1 in that. If I let n be 2, it'll be 3. -1 cubed is also -1. So that'll be 1 over, this n will be 2, square root of 2, and so on. Let me point out something to you here, guys. This thing right here, what kind of number is 2n -1? We haven't seen this before, but what kind of number is 2n -1? Odd or even?
Even.
Oh.
Isn't it odd? 2n's always even, isn't it?
Oh, 2. Okay.
So if you take away 1, you're going to get an odd. And if you raise -1 to an odd power, what's going to happen? You're always going to get a minus, right? So this isn't alternating. Every single one of these things is negative. So it looks like this.
Oh, okay.
So it's not alternating. So let's talk about what we need to do if it's not alternating, because we can't use the alternating series test on it. But you know, every one of them has a -1 in it. So if I looked at that, it would look like, if I pulled out a -1, it would be 1 over the square root of n, wouldn't it? I mean, that's what you're doing, 1, 2, 3, 4. And you know, and that's sort of what the series looks like. You can pull out a minus from a series and look at that thing right there. Now, tell me what that does.
Diverge.
It diverges because it's a p series where p is less than 1. Now, we found out a few sessions ago that multiplying a series by some constant, whether it's negative or positive, doesn't affect the fact that it converges or diverges. If it diverges, you can multiply it by 348. It's still going to diverge, okay? So all I did here was pull out that -1. This thing is going to diverge because it's a p series times a constant. So what that says in this case is that -1 is not included. So I know -1 is not included there. All right, let's try 1. See what happens with 1. Actually, I think that'll be easy. So is everybody okay with my reasoning right here? It's always helpful. I mean, you guys are not used to this, but immediately when I looked at that, I was like, that's an odd number. This isn't going to alternate because it's never going to be positive. Okay, so that's the kind of thing you kind of pick up as tricks as you get better with this stuff. All right, what are we checking? 1. Let's check 1. All right. So I'm going to check 1. And that means I'm just going to plug in to the series the series was minus 1 to the n minus 1. Minus 1 to the n minus 1. And then that's 1 over square root of n. And if I plug in 1 up there, that's 1 to the n. Okay. Now, 1 to the n is what, guys? What's the value of any 1 to any power?
1.
It's 1. Okay. So what we get is the sum from n equal 1 to infinity of minus 1 to the n minus 1 times 1 over the square root of n. Now, the question is, does that diverge or does it converge? Well, look, this is different here. This is n minus 1. If n were 1, it would be 0. If n were 2, it would be 1. If n were 3, it would be 2. This is going to alternate. That is going to alternate. This is an alternating series. Okay? So I'm going to check my conditions for alternating series. What are my conditions for alternating series, guys?
Decrease
I have a
by equal
question.
0.
Okay, this got to go to 0. Okay, what's your question, Alexis?
Why can't we just say it diverges? Because the other one, like, I don't know. I think I'm thinking about a rule. that
Okay.
says, like, if one diverge.
Yeah, let me tell you that. Let me remind you what you're thinking about. Suppose I didn't have that there and I had 1 over n. That's the harmonic series and it diverges. But if it were alternating and it had a 1 over n, the absolute value would converge. That's what we call conditionally convergent.
Okay.
That's what we were doing there, okay? So here, that's pretty clear that goes to 0. You got to also show it's decreasing. That's not hard. If you look at the function f of x equal, if you wrote this as n to the minus 1/2, it would be minus 1/2 n to the minus 3/2, which is minus 1/2 over 1 over the square root of n cubed. N is always a positive number because n starts at 1. That's, see, n starting at 1. So this is less than 0. That means it's decreasing. What I have here is a convergent alternating series. So this interval, let's see, it included 1, but it did not include minus 1. So this interval of convergence looks like that. Now, let me go back to what I said to Alexis a minute ago. This thing does converge here, but its absolute value would be a p-series that does not converge. We call that conditionally convergent. Its absolute value does not converge, and it does. It's conditionally convergent. Okay. So, but now you found what you wanted. You found your interval. Does everybody see what I'm doing?
Yeah.
All right, I want to add one other thing to this, and it's a lot easier. And by the way, if you look at this, and this has to do with what I'm getting ready to say next, your interval of convergence here is between minus 1 and 1, and notice it's centered at 0. It's centered at 0. 0 is halfway in between. That has to do with the fact that these x to the n's, that's just an x to the n. Now I'm going to show you something different that can happen where it can be centered at a different place. All right, let me see if I can go back and find out where the rest of my lecture is. Whoa. Using the ratio test. Decision weighting. That's not what I wanted. Okay, I've got to go back again, find out what I got here. Oh, let's see. I think that's where I was before. That's not it. That's not what I want. Hang on. Try again. Did this on the 26th. That was probably yesterday. Yeah. Okay. All right. Dang, that's not it either. And you know what? The one I need is turned sideways. That isn't gonna work. Hang on, guys. I rewrote this lecture. I might have to write it out from scratch. Okay. Oh, here we go. Here we go, right there. Okay, so yesterday I told you to do these things right here, and we've done 3 and 5, so you kind of know how things are going to play here. If you haven't done the other ones, it'll be good practice to check them 7, 9, 13, do those. All of those had an x to the n power in them. The ones that I ruled out that were in the homework were things that had something besides an x to the n in it, some power of something else. And that looked like this. It says, let C be a real number, and x a variable. A power series in x minus c is a series of the form the sum from n equals 0 to infinity of an times x minus c to the nth. So c is just some number. You could think about the ones we had already done as x minus 0 to the nth, because those were powers of just x to the nth. That would mean in the ones we'd already done, the c was 0. And that's why we say it's centered at 0, because it looks like that. If we have one of these, it has this x minus c in it instead of just x. AKs, all those things are still just constants. The powers that you get here are powers of x minus c, and we say that this is a series centered at c. And you'll see why that is in a minute when I work one of these. Instead of being centered at 0, like this one was, where c was 0, it's going to be centered at a different number. Now, let me just say, before I get deep into this, let me just sort of show you what happens. I may come out with something in the end here. You know, before I came out with something like that, say that was less than 1, we knew that x was between 1 and minus 1. The center of that interval was at 0. If I have powers of other things, it might look like this. And if that's less than 1, here's what that means. It means that what's in there is between 1 and minus 1. I mean, it means the same thing. It's just that it's just not an x anymore. It's an x minus 3. Now, if I move 3 over to this side and to that side, I'll get x will be between 4 and 2. So now you're saying, well, this thing converges for things between 4 and 2. And guess what? What's the halfway between 2 and 4, guys?
3.
It's 3. And that's why we say it's something that ended up centered at 3. Okay, let me do an example. Suppose I had this one right here. It looks different from the ones we did last night, because instead of powers of x here, we've got powers of x minus 3. So what we're really asking is, what are the numbers around 3 where this thing would converge? What are the values of x that if I plugged into here, this series would converge? And it turns out that that interval is going to be centered at 3. Now, I don't do the ratio test any differently at all. I just take this thing, everywhere there's an n, I put in an n plus 1. So I get this. And on the bottom, I put the series itself. I then invert and multiply, just like I did before. I'm then going to try to simplify it. I'm clearly going to have the n plus 1 and the n plus 2. I'm going to have the minus 1 to the n plus 1 and minus 1 to the n. One of those will go, it would be minus 1. But you know what? Its absolute value of minus 1 is just 1. So those powers of minus 1 are irrelevant here. Look at the x minus 3 to the n plus 1 over x minus 3 to the n. Remember, this is x minus 3 to the nth times x minus 3. So what cancels here, guys? What am I left with if I look at that one and that one?
X minus 3.
Yeah, just the x minus 3. Because if you take n away, if you subtract the power in the denominator, you're just left with 1. So here's what I was left with. I was left with the x minus 3 to the first. That one was gone. I was left with n plus 1 over n plus 2. I wrote them separately here, guys, because like I said a minute ago, you're really focused right now on the limit. And the limit is as n goes to infinity. There are no n's in this. So I'm going to look at that, and that's easy. That goes to 1, which means that this limit is the absolute value of x minus 3. Okay? So I found out what the limit was by the ratio test. Now, what does the ratio test say? It says the series converges for x minus 3's absolute value of x minus 3 less than 1. And as I said a minute ago up there, that means x minus 3 is between 1 and minus 1. If you move the 3 over in both directions, you get x being between 2 and 4. Okay, so what we know so far is that if I look at an interval, this thing's definitely going to converge for values of x between 2 and 4. So it converges there. It is going to diverge on the outside. So if you plug in 5 to this thing, it's going to diverge. What you've got here with a power series is that the power is in that you don't have to test all series for a million different numbers. You know the ones it's going to converge for, and you know the ones it's going to diverge for. This will converge if x is 3.5. It won't converge if x is 1 because it's outside that interval. Process is the same after this. I need to check the endpoints. Okay, so that's the next thing I've got to do. So I'm going to check the endpoints here. The endpoints are now 4 and 2. So I will just plug in 4 and I'll check it, and I'll plug in 2. If I plug in 4, guys, 4 minus 3, if you went back up to the original series, there was an x minus 3 there. So 4 minus 3 would have been 1. What I get here is the series, blah, blah, blah. Why did I do that? Minus 1. That was just 1. That wasn't minus 1. That was x minus 3. This is just a 1. Okay. And 1 to the nth is just 1. Yeah, I don't like that. Oh, I was checking.
Wait, that's my.
Oh, I was checking forward. Shoot, I'm sorry. I scrunched up too much stuff here. Hang on a second. This one right here is the one I was looking at. Okay, so what I end up there with there is n equals 0 to infinity. That's just 1. 1 to the nth is 1. Now I get minus 1 to the nth over n plus 1. Okay, I was checking 4. That's an n. This looks really bad. Sorry. Let's do it again. Now.
Where did that 1 to the n come from?
This one right here. All right, go back to the original series. Alexis, there's the original series right there, okay? And I'm checking 4. So I plugged in 4 for it.
Okay.
That's where I got it. Okay?
Yeah.
I miss about a big board. I can't point back to it. I have to scroll back to it. Okay. So, so what I end up with there is this thing right here. Now, everybody take a look at that thing right there. I'm checking 4. What kind of series is that?
Okay.
What kind of series is that? I didn't hear.
Alternating.
It's alternating, isn't it? Okay. Does an go to 0? Does 1 over n plus 1 go to 0?
Yeah.
Yep. And you can show it's decreasing because the derivative of that thing will be minus 1 n plus 1 to the minus 2. Drop that, it'll be a square. It's always negative, so it's decreasing. The derivative shows me it's decreasing. This goes to 0. Converges by the alternating series test. So that says I'm going to include 4 there. Now let's check 2. Let's check 2. Now again, what am I doing? I'm going back to the original series, and this time instead of putting in 4, I'm going to put in 2. But if I put in 2, guys, what do I get in there?
Negative.
-1. So let's go back and see what we got. We got that -1 in there. Now you've got a like base, and you've got n plus n. You're going to add the powers. You get 2n. What kind of number is this, guys? No matter what n is, what kind of number is this?
Positive.
It's positive. Good, because that's even. If I raise -1 to an even power, that's going to be positive. Now I get this. 1 over n plus 1. What's that look like to you?
M divergence. No. It's harmonic.
Yeah, it's harmonic. It started a little further down the line, but it's harmonic. And it's not the nth term divergence test because it does go to 0. That means it has a chance to converge, but it doesn't converge, okay? You could actually use a limit comparison test on this if you wanted to. You don't have to, because you should be able to see it's just a little, it's the harmonic series, but starting a little later, okay? Actually, it's the harmonic series, period.
One person up here, one person downstairs. Stop praying. It's still school time. Doing that shit means that's school.
Nobody's talking to me. Okay, never mind.
No, y'all don't have A's and B's. Y'all have one.
Okay, so guys, it diverges at 2. So my interval of convergence is that.
Every time we do these problems, you want us to say the interval.
Yeah, that's what they're asking in the back. That's how you know from the answer in the back that it converged at 4 and it didn't at 2. So that's what you're going to give me, okay? I'll give you an interval, or you'll give me an interval. Okay. All right, let's do one more. Okay. Here it is, -1 to the nth times n factorial over n cubed x plus 2. Now, if you write x plus 2 with a negative in it, it looks like x minus a -2. My c here is -2. All right, that's my c. We say it's centered at -2. You got to build the minus into it here, guys. So if it's plus, the c is going to be negative. If it's minus, the c is just whatever the number after the negative is. All right, so what it says to me in this case, I haven't done the problem yet, but I know whatever my interval of convergence is, it's going to have a central point of -2. That's all that means. It's centered at -2. Okay, let's do the messy part. Let's do the ratio test. It's messy, but it's not hard. That's the best kind of thing, okay? Aside from not messy, not hard, which never happens. What we're going to look at is we're going to take n plus 1 and plug it in everywhere up through here. So that's what I did. -1 to the n plus 1 factorial over n plus 1 cubed, x plus 2 to the n plus 1. In the bottom, just the series. Series goes down there in the bottom. I'm going to invert and multiply here. And by the way, guys, I can go ahead and and I did it here. The -1s are going to go. Okay, if you looked at that, it would be -1 to the first, but the absolute value of -1 is just going to be 1. And this is just a product. Okay, the rest of it. How about this and this? What's going to be left out of x plus 2 to the n plus 1 over x plus 2 to the n?
X plus 2.
Just an x plus 2. The n's will cancel, and I'll be left with one of them. That's what that thing is right there. Now, what's left out of n plus 1 factorial over n factorial?
N plus 1.
Okay, Alexis, this is the thing we were talking about the other day. When you're doing factorials, right here, n plus 1 factorial would start with n plus 1, and then it would go to n, and then it would go to n minus 1. It drops down 1 every time. If I put it over n factorial, that would start at n minus 1, and so on and so forth. Everything cancels except the n plus 1.
See, you know, you're saying that, but I'm going to, for some reason, I just can't remember that.
Well, let me give you a specific example to remember. Suppose I said 3 plus 1 factorial over 3 factorial. In other words, you'd start counting one earlier, I mean, a bigger number right there. But 3 factorial is just 4. So it's 4, 3, 2, 1. 3 factorial is 3, 2, 1. So what's left?
4.
Just 4. See, everything from n on canceled out. Suppose I did this. I'll come back and finish that one in a second. Oh, shucks. Suppose I did this. N plus 2 factorial over n minus 1 factorial. Everybody look at this because I made up one that's not quite like we've seen. With this one, you're going to start counting down with n plus 2. You count down by ones. So n take away 1, n take away 2, until I get to 3, 2, 1. So do you see how I'm counting down by 1 every time?
Yeah.
Okay. Now, where's n minus 1 going to start? It'll start at n minus 1. If I take away 1, it'll be n minus 2. If I take away another one, it'll be n minus 3. And it's going to count down to 3, 2, 1. Okay, tell me what wipes out.
Everything except for n plus 2, n plus 1.
And n.
And
You got another n there, I think. It starts to wipe out at n minus 1s, doesn't it? So it's these, see, it starts to wipe out there. So what you got left, there was an n left in there.
okay.
Okay? Write it out if you have trouble figuring out what it is. It's the more you do it, you'll pick up on it quick. All right, so let's finish out this next one, or finish out this one. Ugh, that's not what I want to do. I want to erase it. Okay. Okay. So I'm looking at this one right here. I got everything canceled out except all of this stuff. So I've got my absolute value of 2 that's right there. Now, I want you to look at this thing right here. What's the highest power in the numerator? Yeah, it's into the 4th, isn't it?
4.
And then there's an n cubed. Where's that thing going?
Infinity.
It's going to infinity. The only way this can be less than 1 is if this is 0. Because otherwise it's going to go to infinity. Where would it be 0 then? Where would the x plus 2 be 0?
Negative 2.
So we say it converges only for the isolated point minus 2. So if the n part goes to infinity, it converges only where that part is 0. One more, and we'll have an example of everything that can happen. So guys, in this one, the other one had this interval of convergence here. This one just is converging at an isolated point because everywhere else it was going to infinity. Okay, this is the only thing that would make it 0, and that's the only thing that would make it less than 1. All right, let's look at the last one. The last one looks like this. X minus 1 to the nth over n factorial from 1 to infinity. I'm going to cut to the chase here, guys. You put in n plus 1 and an n plus 1 here. And then you're going to put in this thing, but I already went ahead and inverted it. See, I'm in a hurry to get to the end of the lecture, and I was in a hurry to get to the end of it when I was writing it. You see what I did? I just went ahead and inverted and multiplied. Okay, let's look at this thing. What about x minus 1 to the n plus 1 over x minus 1?
Minus 1.
X minus 1.
It's just x minus 1, isn't it? It's just x minus 1. Because the n part of it takes out that, and just leaves me with that thing to the first. All right, Alexis, you're on here. This is n minus 1, n minus 2. This is n plus 1, n minus 1, n minus 2. It's going to wipe out after which term?
Wait, hold on.
Okay.
After n.
Yes, so what's left?
N plus 1.
Okay, you got it. I'm good. Okay, so now I've got this, the limit as n goes to infinity. What's the limit as n goes to infinity of this n piece right here?
0.
0. You know what? It doesn't matter what x is, because no matter what x is, 0 times anything is just going to be what? 0. And that means it's always less than 1. No matter what x is, it's always less than 1. What does this say? Doesn't matter what x is. It converges for all x. So guys, if you get a limit of infinity, it only converges at an isolated point. If you get a limit of 0 on this thing, it converges everywhere. If you get some number, that's when you get an interval. So there are only 3 things that can happen. There are only 3 things that can happen. It converges everywhere for all x. It converges only at the place where your x to the nth or x minus c to the nth is 0. Or it converges on some interval. Now, I don't know why I even make up an assignment sheet. Tonight, you're going to stay on the same page. Makes no difference what the assignment sheet says. But now you can do the ones that aren't centered at 0. So do as many as you can. Your next quiz is on power series. I would, if I were you, and I think I've put it in Moodle, I'll double check. And I don't even know when I put it due, but we'll look at it tomorrow. It's definitely not tomorrow, because if it were, I'd have to move it anyway, because we didn't get everything we needed to get to. I'll let you know when it is, but you might want to look at it. But that's, keep doing the stuff on 572. Keep doing the stuff on 572.
So the quiz is not due?
I don't know when I had it due. Does anybody have it in front of them? You got Moodle in front of you?
No, but I know it's on Moodle.
Yeah, well, there's nothing due right now. I'll tell you tomorrow, okay? There's nothing due right now. And I'll try to get your quizzes back. Who's got their quiz to me? I have hardly looked at that. Alexis, I saw yours, I think. Has everybody gotten it to me, this last one?
Mm-mm.
Okay, make that bottom problem, that's that number down in that denominator there, a cube. Because that's what I think I meant it to be.
A 2?
A cube.
Oh, okay. I was like, man, I'm not trying to rewrite it all.
Did you do a cube?
Yeah, I did it as a cube.
Okay, good. Right. If you haven't handed it to me, do it as a cube, and give me that stuff, you know, sometime today or early in the evening. I'll probably get to it, but get it to me before we got another one due. Okay. Stuff starting to back up on me. All right. Does anybody got a question? Yeah, Tierra.
Yes.
Yes.
Can you let me know if you get it? I just sent it, but this app hasn't been working for me lately.
Let me see. Let's see if I can bring it up here.
Because it took like 5 hours to send something.
Really?
Yes, I tried sending it 5 times.
All right,
when I was
let me
about to go to sleep, it came through.
Okay, let me check. I got it. Okay?
Yeah, okay.
All right. Anybody else got a question? We okay? Yon, you okay? Alexis, Deborah, you okay?
Yeah.
Walking better?
Yeah.
Takes a while. At least they didn't have to put your whole leg in a cast. All right. I'll see you guys. I'll see you guys tomorrow. Just work on this same page tonight, okay?
Ernie.
Sign off. See you later.